Lisp is a family of computer programming languages with a long history and a distinctive, fully parenthesized Polish prefix notation. Originally specified in 1958, Lisp is the second oldest high-level programming language in widespread use today. Only Fortran is older. Like Fortran, Lisp has changed a great deal since its early days, and a number of dialects have existed over its history. Today, the most widely known general-purpose Lisp dialects are Common Lisp and Scheme. Lisp was originally created as a practical mathematical notation for computer programs, influenced by the notation of Alonzo Church's lambda calculus. It quickly became the favored programming language for artificial intelligence research. As one of the earliest programming languages, Lisp pioneered many ideas in computer science, including tree data structures, automatic storage management, dynamic typing, conditionals, higher-order functions, recursion, and the self-hosting compiler. The name Lisp derives from Lisp processor. Linked lists are one of Lisp's major data structures, and Lisp source code is itself made up of lists. As a result, Lisp programs can manipulate source code as a data structure, giving rise to the macro systems that allow programmers to create new syntax or new domain-specific languages embedded in Lisp. The interchangeability of code and data gives Lisp its instantly recognizable syntax. All program code is written as S expressions, or parenthesized lists. A function call or syntactic form is written as a list with the function or operator's name first, and the arguments following. For instance, a function f that takes 3 arguments would be called as history. Lisp was invented by John McCarthy in 1958 while he was at the Massachusetts Institute of Technology. McCarthy published its design in a paper in Communications of the ACM in 1960. Untitled Recursive Functions of Symbolic Expressions and Their Computation by Machine, Part 1. He showed that with a few simple operators in a notation for functions, one can build a Turing-complete language for algorithms. Information processing language was the first AI language, from 1955 or 1956, and already included many of the concepts, such as list processing and recursion, which came to be used in Lisp. McCarthy's original notation used bracketed M expressions that would be translated into S expressions. As an example, the M expression car, cons A, B, is equivalent to the S expression. Once Lisp was implemented, programmers rapidly chose to use S expressions, and M expressions were abandoned. M expressions surfaced again, with short-lived attempts of MLISP by Horace Annear and CGOL by Vaughan Pratt. Lisp was first implemented by Steve Russell on an IBM 704 computer. Russell had read McCarthy's paper, and realized that the Lisp eval function could be implemented in machine code. The result was a working Lisp interpreter which could be used to run Lisp programs, or more properly, evaluate Lisp expressions. 2 assembly language macros for the IBM 704 became the primitive operations for decomposing lists, char and cdr. From the context, it is clear that the term register is used here to mean memory register, nowadays called memory location. Lisp dialects still use char and cdr for the operations that return the first item in a list and the rest of the list respectively. The first complete Lisp compiler, written in Lisp, was implemented in 1962 by Tim Hart and Mike Levin at MIT. This compiler introduced the Lisp model of incremental compilation, in which compiled and interpreted functions can intermix freely. The language used in Hart and Levin's memo is much closer to modern Lisp style than McCarthy's earlier code. Lisp was a difficult system to implement with the compiler techniques and stock hardware of the 1970s. Garbage collection routines, developed by then MIT graduate student Daniel Edwards, made it practical to run Lisp on general-purpose computing systems, but efficiency was still a problem. This led to the creation of Lisp machines. dedicated hardware for running Lisp environments and programs. Advances in both computer hardware and compiler technology soon made Lisp machines obsolete. During the 1980s and 1990s, a great effort was made to unify the work on new Lisp dialects into a single language. The new language, Common Lisp, was somewhat compatible with the dialects it replaced. In 1994, ANSI published the Common Lisp standard, ANSI by 3.226-1994 Information Technology Programming Language Common Lisp connection to artificial intelligence. Since its inception, Lisp was closely connected with the artificial intelligence research community, especially on PDP-10 systems. Lisp was used as the implementation of the programming language microplanner, which was used in the famous AI system SHRDLU. In the 1970s, as AI research spawned commercial offshoots, the performance of existing Lisp systems became a growing issue. Genealogy and Variants. Over its 50-year history, Lisp has spawned many variations on the core theme of an S-expression language. Moreover, each given dialect may have several implementations. For instance, there are more than a dozen implementations of Common Lisp. Differences between dialects may be quite visible. For instance, Common Lisp uses the keyword defunct to name a function, but scheme uses define. Within a dialect that is standardized, however, conforming implementations support the same core language, but with different extensions and libraries. Historically significant dialects. Lisp 1 first implementation. Lisp 1.5 first widely distributed version, developed by McCarthy and others at MIT. So named because it contained several improvements on the original Lisp 1 interpreter, but was not a major restructuring as the planned Lisp 2 would be. Stanford Lisp 1.6. This was a successor to Lisp 1.5 developed at the Stanford AI Lab, and widely distributed to PDP-10 systems running the TOPS 10 operating system. It was rendered obsolete by MacLisp and Interlisp. MACLISP, developed for MIT's Project Mac, direct descendant of Lisp 1.5. It ran on the PDP-10 and Multics systems. Interlisp, developed at BBN Technologies for PDP-10 systems running the Tenix operating system. Later adopted as a West Coast Lisp for the Xerox Lisp machines is Interlisp D. A small version called Interlisp 65 was published for the 6502-based Atari 8-bit family computer line. For quite some time MacLisp and Interlisp were strong competitors. Franz Lisp, originally a Berkeley project, later developed by Franz Inc. The name is a humorous deformation of the name Franz Lisp, and does not refer to Allegro Common Lisp, the dialect of Common Lisp sold by Franz Inc. in more recent years. XLISP, which Autolisp was based on. Standard Lisp and Portable Standard Lisp were widely used and ported, especially with the computer algebra system Reduce. Zeta Lisp, also known as Lisp Machine Lisp, used on the Lisp machines, direct descendant of MacLisp. Zeta Lisp had a big influence on Common Lisp. Lisp is a French Lisp dialect. One of the first interface builders was written in Lisp. Scheme. Common Lisp, as described by Common Lisp, a language, a consolidation of several divergent attempts to create successor dialects to MacLisp, with substantive influences from the Scheme dialect as well. This version of Common Lisp was available for wide-ranging platforms and was accepted by many as a de facto standard until the publication of ANSI. Common Lisp. Dylan was in its first version a mix of Scheme with the Common Lisp object system. ULisp, attempt to develop a new efficient and cleaned-up Lisp. ISLISP, attempt to develop a new efficient and cleaned-up Lisp. Standardized as ISO, IEC 13816 to 1997 and later revised as ISO, IEC 13816 to 2007. Information technology, programming languages, their environments and system software interfaces, programming language ISLISP, IEEE Scheme IEEE Standard, 1178-1990. ANSI Common Lisp, an American National Standards Institute standard for Common Lisp, created by Subcommittee X3J13, chartered to begin with Common Lisp. The language is a base document and to work through a public consensus process to find solutions to shared issues of portability of programs and compatibility of Common Lisp implementations. Although formally an ANSI standard, the implementation, sale, use, and influence of ANSI Common Lisp has been and continues to be seen worldwide. ACL2, or a computational logic for applicative Common Lisp, an applicative variant of Common Lisp. ACL2 is both a programming language in which you can model computer systems and a tool to help proving properties of those models. Clojure, a modern dialect of Lisp which compiles to the Java virtual machine and handles concurrency very well. 2000 present. After having declined somewhat in the 1990s, Lisp has recently experienced a resurgence of interest. Most new activity is focused around implementations of Common Lisp as well as Clojure, Racket, Scheme and Emacs Lisp, and includes the development of new portable libraries and applications. Many new Lisp programmers were inspired by writers such as Paul Graham and Eric S. Raymond to pursue a language others considered antiquated. New Lisp programmers often describe the language as an eye-opening experience and claim to be substantially more productive than in other languages. This increase in awareness may be contrasted to the AI winter and Lisp's brief gain in the mid-1990s. Dan Weinrib lists in his survey of Common Lisp implementations 11 actively maintained Common Lisp implementations. Sine Common Lisp is a new commercial implementation forked from CMUCL with a first release in 2002. The open source community has created new supporting infrastructure. Clicky is a wiki that collects Common Lisp-related information. The Common Lisp directory lists resources. #Lisp is a popular IRC channel. Lisp Haste supports the sharing and commenting of code snippets. Planet Lisp collects the contents of various Lisp-related blogs. On Lisp forum, users discuss Lisp topics. Lisp Jobs is a service for announcing job offers, and there is a weekly news service, Weekly Lisp News. Common-Lisp.net is a hosting site for open-source Common Lisp projects. Quick Lisp is a library manager for Common Lisp. 50 years of Lisp has been celebrated at Lisp 50 at Uppsala. There are regular local user meetings in Boston, Vancouver, and Hamburg. Other events include the European Common Lisp Meeting, the European Lisp Symposium and an International Lisp Conference. The Scheme community actively maintains over 20 implementations. Several significant new implementations have been developed in the last few years. The revised 5 report on the algorithmic language Scheme standard of Scheme was widely accepted in the Scheme community. The Scheme requests for implementation process has created a lot of quasi-standard libraries and extensions for Scheme. User communities of individual Scheme implementations continue to grow. A new language standardization process was started in 2003 and led to the R6RS Scheme standard in 2007. Academic use of Scheme for teaching computer science seems to have declined somewhat. Some universities, such as MIT, are no longer using Scheme in their computer science introductory courses. There are several new dialects of Lisp: Arc, High, New, Clojure, Liskell, LFE and Racket. Major dialects, Common Lisp and Scheme, represent two major streams of Lisp development. These languages embody significantly different design choices. Common Lisp is a successor to MacLisp. The primary influences were Lisp Machine Lisp, MacLisp, NIL, S1 Lisp, Spice Lisp, and Scheme. It has many of the features of Lisp Machine Lisp, but was designed to be efficiently implementable on any personal computer or workstation. Common Lisp has a large language standard including many built-in data types, functions, macros and other language elements, as well as an object system. Common Lisp also borrowed certain features from schemes such as lexical scoping and lexical closures. Scheme is a more minimalist design, with a much smaller set of standard features but with certain implementation features not necessarily found in Common Lisp. Scheme is a statically scoped and properly tail recursive dialect of the Lisp programming language invented by Guy Lewis Steele Jr. and Gerald J. Sussman. It was designed to have exceptionally clear and simple semantics and few different ways to form expressions. A wide variety of programming paradigms, including imperative, functional, and message-passing styles, find convenient expression in Scheme. Scheme continues to evolve with a series of standards and a series of Scheme requests for implementation. Clojure is a recent dialect of Lisp that principally targets the Java virtual machine, as well as the CLI, the Python VM, the Ruby VMYARV, and compiling to JavaScript. It is designed to be a pragmatic general-purpose language. Clojure draws considerable influences from Haskell and places a very strong emphasis on immutability. Every feature supported by Clojure is supported at runtime. Clojure provides access to Java frameworks and libraries, with optional type hints and type inference, so that calls to Java can avoid reflection and enable fast primitive operations. In addition, Lisp dialects are used as scripting languages in a number of applications, with the most well-known being Emacs Lisp in the Emacs editor, AutoLisp and later Visual Lisp in AutoCAD, Nyquist in Audacity, Scheme in LilyPond. The potential small size of a useful Scheme interpreter makes it particularly popular for embedded scripting. Examples include SIOD and TinyScheme, both of which have been successfully embedded in the GIMP image processor under the generic name ScriptFu. LIBREP, a Lisp interpreter by John Harper originally based on the Emacs Lisp language, has been embedded in the Sawfish window manager. Language innovations. Lisp was the first language where the structure of program code is represented faithfully and directly in a standard data structure, a quality much later dubbed homoiconicity. As a result, Lisp functions can be manipulated, altered or even created within a Lisp program without lower-level manipulations. This is generally considered one of the primary advantages of the language with regard to its expressive power, and makes the language suitable for syntactic macros and metacircular evaluation. A conditional using an if-then-else syntax was invented by McCarthy in a Fortran context. He proposed its inclusion in ALGOL, but it was not made part of the ALGOL 58 specification. For Lisp, McCarthy used the more general constructor. ALGOL 60 took up if-then-else and popularized it. Lisp deeply influenced Alan Kay, the leader of the research on Smalltalk, and then in turn Lisp was influenced by Smalltalk. By adopting object-oriented programming features in the late 1970s, the Flavors object system introduced multiple inheritance. Lisp introduced the concept of automatic garbage collection, in which the system walks the heap looking for unused memory. Progress in modern sophisticated garbage collection algorithms such as generational garbage collection was stimulated by its use in Lisp. Edgar W. Dijkstra in his 1972 Turing Award lecture said, with a few very basic principles at its foundation, Lisp has shown a remarkable stability. Besides that, Lisp has been the carrier for a considerable number of, in a sense, our most sophisticated computer applications. Lisp has jokingly been described as the most intelligent way to misuse a computer. I think that description a great compliment because it transmits the full flavor of liberation. It has assisted a number of our most gifted fellow humans in thinking previously impossible thoughts, largely because of its resource requirements. With respect to early computing hardware, Lisp did not become as popular outside of the AI community as Fortran and the ALGOL-descended C language. Because of its suitability to complex and dynamic applications, Lisp is currently enjoying some resurgence of popular interest.